Okay, I think we're rolling. So hello everyone, welcome to the third installment of the Inline-Four workshops hosted by McGill Academy. And essentially in this particular workshop, we're going to be catting the crankshaft of our mechanism. So essentially there's no audience at the moment, so this is going to be a recording for those who are interested in continuing the workshop or those who come across it afterwards and are perhaps intrigued by the CAD of a crankshaft. So let's get started. So I'm going to share my screen here, and we're going to swap to our Solidworks. So I've created a new part file in IPS units. Keep in mind that they're not going to be accurate to an actual crankshaft due to a dimensioning error that we made in a previous workshop. So essentially, we're sticking with inches, even though this should probably be in centimeters. So what I'm going to do is I'm going to create a new sketch. And I'm going to select the right plane. And essentially, we took measurements from our previous workshops of our little connecting rods. And what we're going to do is we're going to make a crankshaft according to those dimensions. So initially, what I'm going to do is I'm going to select a circle and give it a diameter. So using the Smart Dimension tool, give it a diameter of 4 inches. And I go into features, extrude, and we're going to extrude that by 2 inches. So in the blind, with the blind feature. So that essentially means it'll go through anything as long as if it's within that 2-inch depth. As well, we're going to create a new sketch on the face of our cylinder here. Snap to the location, fit. And I'm going to make this a circle with diameter 5. Just giving that. And now that all of our lines are black, like the previous sketch and fully defined, we're going to extrude this one as well. And this one will be extruded by 0.5 inches. Nice. So these first 2 parts were pretty easy. And that's why I sort of went through it quickly. But for this next sketch, there's a lot of details that we're actually replicating from our initial piston design. So you're going to have to follow along fairly closely for the dimensions here for it to make sense in the context of the assembly. So I'm going to make a new sketch on the front face of our newest extrusion. And I'm going to snap fit that once more. And essentially what I'm going to do is I'm going to make an arbitrary 3-point arc that's horizontal like so. And what I'm going to do is I'm going to add some relations first. So I'm going to click on either end, shift click on either end of this arc. And I'm going to give it a horizontal dimension or horizontal relation. For this top little vertex here, so this is where the radius of our arc is actually defined, the point at which we drop it down and we'll create the radius of our arc. What I'm going to do is I'm going to make sure this is central to our sketch. So I click on that point, I shift click on the origin, and I'll give it a vertical relation. So as you can see, the arc is actually right in the center of our sketch. As well, we're going to give a dimension of, I think it was, 1.3 inches to the vertical height of these two points. That should be good in that regard. And then in terms of our horizontal length, so the distance at which the furthest point of the arc reaches the origin, we're going to give that a distance of 4.49 inches. Okay. Finally, we're going to give ourselves a radius. So if you just click on the arc itself, it'll prompt you with a radius. And I'm going to give a radius of 7.3 inches. So as you can see, everything is still fully defined. So that is perfect. And we're going to move all the dimensions to this side just for clarity. So now the next step would be to make another arbitrary 3-point arc. We're going to click somewhere here. It doesn't really matter. And essentially this whole sketch, what we're going to be creating is the counterweight of, or one of the counterweights of our crankshaft. So the big sort of egg-shaped components that will sway alongside the piston and sort of keep it in place, clamping it on either end. So it'll provide a normal force in that regard. So what I'm going to do for this one now is I'm going to select the top vertex of our arc, and I'm going to click the origin. Essentially, what I'm going to do is I'm going to give it a horizontal distance of 3.18 inches. Again, these may seem pretty arbitrary. They're actually dimensions that we pulled from our initial assembly. As well, what I'm going to do is I'm going to click on the arc itself and give it a dimension of 13.74 inches. So that should look like that. And we're going to actually move this down a little bit. It doesn't really matter how far you move it down, because the relations will actually sort the whole sketch out once we're done with the remnants of the sketch. Finally, I'm going to click the Mirror Entities tool, and I'm going to select this arc that we made. And essentially what I want to do is I want to mirror it on the other side of our sketch without having to recreate the whole thing from scratch. So we're going to click Mirror About, and we're going to click on the Feature Manager Design Tree. And what we can do is select the front plane. So as you can see, it actually cuts right in the middle of our sketch and sort of acts as an axis. So if you click that and press OK, you'll see that it mirrors perfectly. We're going to apply another relation. So you click on the outer edge of our arc here, and I'm going to shift click on this one, and we're going to say horizontal. And that should help us out with the arc for now. I'm going to create a new 3-point arc connecting these two. And since these two are centered because of the fact that they're symmetric, we can make a new arc on top like this without any concerns. And you'll notice that the center line, or the axis of this arc, is directly above our origin. So that shows that we've actually done everything perfectly up till now. We're going to give this guy a dimension of, I think it was 3.6 inches for the radius. As well, if we click on this arc, and if we shift click on our new arc, and if we press tangent, you'll notice that everything is fully constrained now. So essentially what we did there with the tangent relation is we made sure that this is a rounded surface. So essentially, if we were to keep the two arcs as they were, there's a chance there would have actually been a slight, almost bump or like a roughness to our shape. So by selecting tangent, we ensure that it's one smooth line that actually curves all throughout. So this is what we want. And now that this is fully defined, we can actually extrude this. So I'm going to extrude it by, let me see, my instructions tell me 1.75 inches. And these instructions will also be posted on McGill Academy's website. So this is what we should have so far. It's starting to come together. So now we're going to make a new sketch on the surface of our object here. And what I'm going to do, so I'm going to make a new circle, just an arbitrary circle, and I'm going to give it a dimension of 3.8 inches for the diameter. Okay. And what we can do is give it a vertical relation such that it doesn't move relative to our origin horizontally by that metric. And what I'm going to do is I'm going to click the bottom vertex of our previous extrusion, and I'm going to select the midpoint, or the center of our new circle. And I'm going to give it a dimension of 7.96 inches. Perfect. And this is sort of where you want the circle to be vaguely positioned. So it's fully defined now. We can sketch this. Extrude this. So what we're going to do is we're going to extrude it by half of the length that we actually want for this part. And you'll see why. So 1.1 inches is how much I'm going to extrude this by. And essentially, what this will allow us to do is to mirror everything very easily, actually. So what we can do is we can click mirror here. And essentially what we want to do is we want to click features to mirror. And we'll click this extrusion, as well as the actual part that we just extruded. And for the mirror face slash plane, we're going to click on the front face of this new extrusion. So as you can see, we're actually completing our assembly very easily like this without having to do everything from scratch. So if we press OK, oh, that didn't show up for some reason. My apologies. Let me see. Huh, that's peculiar. Okay, let's try this again. So if I click on this front face here, and for features to mirror, I'm going to click this guy and this guy. Okay, that's peculiar. Okay, no worries at all. We can actually do it from scratch if we need to. So let's do that. So what I'm going to do then is I'm going to extend this extrusion. For some reason, my mirror tool isn't working right now, but we'll skip ahead. So I'm going to extrude it the full 2.2 inches. So we did halfway, 1.1. We're going to extrude by 2.2. And for the sake of this tutorial, I'm going to use the Convert Entities tool for the next portion. So what I did is I created a new sketch on this new front surface that we created. And I'm going to click Convert Entities. And essentially what Convert Entities does is it essentially takes the face that we select. So we selected this previous face that we sketched up before. And what it does is it essentially projects it onto our new sketch. So think of it almost like a copying tool, but if you've ever done linear algebra, it's a projection. So say if it was off by an angle, it only get maybe half of that if it's at a 45-degree angle. So if we press OK by selecting that face, you'll notice we've actually copied our sketch from before without having to actually re-sketch everything. So it's a very convenient tool. And I'm going to extrude it by the same amount that we extruded this first sketch that we made. So this one was done with a 1.75 inch extrusion. So if we press OK there we go. So now we have our, we have a new, what do you call it? Counterweight. So we're starting to come along a little bit here. I'm just going to stop sharing for a moment, 1 second. Okay, and we're back. Sorry about that. So if I go back and sketch once more, I'm going to sketch on the front face of our new extrusion. And what I'm going to do is I'm going to convert this first face that we made. So essentially, we're extending the chain. And I'm going to extrude this guy by 6 inches. So it should look something like this. And you should have a diameter of 4 inches for this shaft. Okay, all right. So let's see. What else can we do here? Okay, so for this next step, so this one's actually pretty creative and I do like it quite a bit. But essentially what we're gonna do is we're gonna make a new sketch on the front face of this new extrusion. And once again, we're gonna use the Convert Entities tool. And now you may be thinking to yourself, Nima, why are you converting the same face again? Doesn't this counterweight need to be upside down if you're familiar with a crankshaft design? And you're actually right there. So what we're going to do is we're going to click on, so if we're within the sketch portion, under this little arrow within Move Entities, we have a Rotate Entities option. And essentially what we can do is click this entire arc, so this entire sort of piece of rotation. And essentially what we want to do is we want to rotate it about the center of rotation, which is going to be this point here. That's what we made our whole design about. And we're going to rotate it by 180 degrees. So if we rotate that, oh, sorry, it didn't work. My apologies. Let's try that again. So we're going to click each of these entities to rotate. And for the center of rotation, we're going to click our point here, and we're going to rotate by 180 degrees. So essentially, when we do that, peculiar. Here, sorry. Let me work this out. I'm going to check my instructions once more. For some reason, this isn't. I figured it out. Yep, we forgot to Sorry about that. So if we click our center of rotation and rotate it, essentially what we want to do is we want to uncheck the keep relations box. So as you can see, this is actually not defined, so we'll need to define it once more, which is perfectly fine. So we'll just create a quick definition of everything, and everything's in place. So we don't need to worry about the accuracy of our actual definitions here. So if we press OK there, and if we give this one another radius, and this guy should be, they should have a horizontal relation here. And I think, sorry, one second. I think there may be a new participant joining. No, we're good. Okay, perfect. Let's see. We have this relation here. And the whole, yeah, relations may seem a little bit tedious, and dimensioning may be a bit annoying, but it's very necessary within your sketches, because if you change a certain feature within your object, you could risk the risk of potentially losing your dimensions if you change something drastically. So you want to make sure everything's constrained to some particular reference. Usually what you want is some sort of baseline reference. So let's see, another relationship here. Okay, these guys should be tangent, as well as these guys. And then let's see, are we missing? We seem to be missing a decent amount of relations here. Perfect. Now everything's fully defined, and you can disregard all of these dimensions. So what we can do is extrude this by 1.75 inches and obtain a similar result to what we had before. Okay, and we can do the same thing with the circle that we had, or the cylinder that we made before. So what I'm going to do is I'm going to sketch on this front face, and I'm going to use the convert entities tool once more. Oh, whoops, I accidentally selected a face that is perpendicular to the sketch plane. What you need to do is actually click on this face, which is either parallel or oblique to the sketch plane. So we have this particular circle here, but what we're going to do is we're going to rotate this. So using the same tool that we just used before, we're going to click on this as our entity to rotate. Our center of rotation is going to be our little point here, and we're going to rotate it by 180 degrees. So if we do that, it'll get rid of our dimensions once more. And essentially what we want to do is we want to give this a dimension of 3.8 inches. So that was our previous diameter. And if we snap fit, we want this to be 3.5 inches away. So approximately that's what we had before. And we want to apply a vertical relation to these two such that they don't move relative to each other. And if we extrude this once more, so what we want to do is we want to extrude it by the same amount that we did before. So let's see. This one was 2.2 inches, if I remember from before. And essentially what we can do is use the same technique that we used to copy this extrusion here. So with a new sketch on this face, what I'm going to do is I'm going to go and press convert entities once more on this particular face. And then that's fully defined, so we can extrude it by 1.75 inches. Sorry about that. Nice. So as you can see, it's starting to come along decently well. So that is perfect. So let's see, what else can we do? We're going to make a new sketch on the front face, and we're going to extend this axle sort of connection that we had before. So what we're going to do is we're going to convert entities once more. So this gives us a circle of diameter 4 at the same location that we had before. But what we're going to do is we're going to extrude this by 3 inches, not by 4. And the reason for it is because we actually want to mirror the entire body. So what I'm going to do is I'm going to press mirror. For the mirror face / plane, I'm going to click this front face. And for the features to mirror, I'm going to select everything before it. And if we press OK, so this should actually give us a partial preview. It did not do that properly. My apologies. Here, let me retry that. So if we mirror and click for our bodies to mirror, so it's a full solid body, we'll click that. There you go. We have our entire design right there. And essentially what we can do is we can add some details to the ends of our shaft here. So what I'm going to do actually is, let's see. I'm going to sketch a new circle identical to the main bearing journal and extrude it by another 4-inch. Okay, so if we can do that. 1 second, let me just stop sharing here. Okay, so for the next portion, what we need to do is take our new end that we have here. So this is the mirrored portion. And what I'm going to do is I'm going to create a new sketch. And I'm going to click on this front face here. And I'm going to convert the entity of this front face. So essentially, I'm projecting this diameter 4 cylinder onto the end. And essentially what I'm going to do is I'm going to create a part that accommodates for the belt. So what we're going to do is we're going to take this new circle and extrude it by 4 inches. That's perfect. Then it merges. And we're going to create a new sketch on top of that. And essentially what I'm going to do is I'm going to create a new circle, but this one, if we use the Convert Entities tool, will accommodate that larger circle that we had before, that larger cylinder. So this is actually a diameter of 5 for this second circle. And we're going to extrude this guy out by, let me see, 2 inches, according to what we've written. So 2 inches should be adequate. Brilliant. So now what we want to do is we want to make use of our sweep cut tool. So what I'm going to do is I'm going to create a new plane. So this plane is essentially going to mark the halfway point for our sweep cut. And you'll see in the context of our sketch how this plane will be useful. But I'm going to click this top half as our first reference. I'm going to click the bottom edge as our second reference. And as you can see, it automatically creates a plane that's in the middle of both of these. So that's a very useful trick. And essentially what I'm going to do is I'm going to create a new sketch. But what I want it to be on is if we go into our feature tree. So the front plane seems to be the best option because as you can see, it cuts right in the middle of our plane. So it's perpendicular, but we'll still have a nice region to have our sketch on. So I'm going to click on the front plane here. And having the front plane selected, I'm going to snap our view to our little part that we have here. And I'm going to make the following feature. So we will make a line from the top edge of this cylinder to our plane. That is, let's see, I said it's going to be 0.5 inches apart from the outer edge of our cylinder. Okay, perfect. Then we're going to make a diagonal cut in. Doesn't need to be perfect. And we're going to have another point connect to the actual plane. So this point here should be, let me see, 0.25 inches apart. So 0.25, okay. And altogether, the actual depth of this cut should be 0.5 inches. Yes, 0.5. Okay, and as you can see, this is fully defined. And what I'm going to do is I'm actually going to mirror this about our axis. So I'm going to click these 3 lines that we made, and we're going to mirror it about this plane that we just made. And as you can see, we have this perfect sort of cut or groove that we're going to actually cut into our cylinder. So let me see. We can apply the sweep cut feature or the revolved cut feature. Both work. For the revolved cut feature, essentially what you'd need to do is create an axis of rotation. But for this, we don't have to do that. So let's do that. So If I exit our sketch and click on swept cut, having our profile selected, essentially for the guide curve, what we can do is follow the path that we made. So let's see. It's going to be on a sketch profile, and let me see. So, okay. I don't believe we actually made the path for it. So what I'm going to do is I'm actually going to make a new axis, and we'll use the revolved cut. So let's get rid of this, click on that cylinder, and there you go. We have a new axis, and what we can do is make a revolved cut, clicking this, this sketch that we just made. So for the selected contours, oh, whoops. Let me bring that back. For our selected contours, we're going to click that sketch that we just made. And for our axis of revolution, we're going to click this axis. And it's going to be a 360-degree cut that you see fits like so. There's alternative ways of making this particular feature. Like what we could have done is we could have made 3 different cylinders and then put a chamfer in between, or have a tapered cut. But this works as well. This is, I'd say this is the preferable option. And essentially that rounds off our crankshaft. So in the next tutorial, what we'll be making is the actual casing for the pistons. So we'll be making the cylinders in which they fit into. And we'll also work on a motion study for all of this. So that pretty much wraps up workshop 3. Thanks for watching, and I hope this was of use to you. Yep, okay.